Every year, wildfires scorch millions of acres across the United States, leaving behind a trail of devastation. Homes are lost, ecosystems are destroyed, and countless lives, human and animal alike, are forever altered. But amidst this chaos, there's a silent observer in the night sky, watching over the flames: the moon. At first glance, the moon and wildfires seem worlds apart, literally and metaphorically. One is a celestial body hanging in the vastness of space, while the other is a terrestrial disaster caused by heat, drought, and human activity. Yet, as we peel back the layers of science, mythology, and history, a surprising connection begins to emerge. A connection that's as much about the forces of nature as it is about our understanding of the universe. Wildfires are among the most destructive natural events on Earth. In 2023 alone, wildfires in the US burned over 10 million acres, releasing billions of tons of carbon dioxide into the atmosphere. But wildfires are not just about destruction. They're part of a natural cycle, one that clears out dead vegetation, replenishes soil nutrients, and even triggers new growth. However, in recent decades, climate change has tipped the balance. Rising temperatures, prolonged droughts, and stronger winds have turned what were once manageable fires into unstoppable infernos. In the United States, the West Coast has borne the brunt of these disasters, with California, Oregon, and Washington experiencing record-breaking wildfires year after year. But what drives these massive fires? On the surface, the answers seem straightforward: dry conditions, high winds, and human negligence. Yet, hidden within this complex web of factors lies a question few have dared to ask. Could the moon, our planet's oldest companion, play a role in this unfolding drama? The moon has always been a source of fascination. For millennia, it has inspired poets, guided sailors, and marked the passage of time. Scientifically, it's much more than a luminous orb lighting up the night sky. The moon exerts a gravitational pull on Earth so powerful that it controls our tides, subtly affects our planet's rotation, and even stabilizes our climate. Recent studies suggest that the moon's cycles may have a subtle but measurable impact on Earth's weather patterns. For instance, during a full moon, the increased gravitational pull can affect atmospheric pressure, which in turn influences wind speeds and humidity levels, two key ingredients in wildfire formation. Moreover, the moon's light itself plays a role. Forest ecosystems, for example, respond to the intensity of moonlight. Animals adjust their behaviors, plants subtly shift their growth patterns, and even soil microbes react to the nocturnal glow. Could it be possible that this interplay between light, gravity, and Earth's ecosystems contributes to conditions ripe for wildfires? The moon and wildfires, two phenomena that couldn't seem more different. And yet, nature is full of such unexpected connections. The moon's gravitational influence on tides, for instance, is a reminder of how deeply intertwined our planet is with its celestial neighbor. In the same way, wildfires are part of a larger natural system that, when disrupted, sends shockwaves through the environment. This brings us to a deeper question. What can these connections teach us about our world? If the moon's phases influence atmospheric conditions, and if these conditions impact the likelihood of wildfires, then understanding this relationship could be critical, not just for predicting disasters, but for reshaping the way we see the Earth-Moon relationship. Over the next hour, we'll explore this mysterious connection between wildfires and the moon. We'll dive into the science of lunar influence on Earth's atmosphere, uncover the myths and stories that link the moon to fire, and examine how understanding this relationship could reshape our efforts to combat climate change. By the end of this journey, you might see the moon, not just as a silent witness to Earth's struggles, but as an active participant in the story of our planet. A story where fire and light, destruction and renewal, Earth and moon are all inextricably linked. The moon, our eternal companion, holds secrets that stretch across time, space, and even the fiery landscapes of Earth. Let's uncover these mysteries together. If you find this video helpful, please give us a subscribe. A small compliment from you is a huge motivation for us. The moon's influence on Earth. The gravitational pull of the moon and its earthly effects. We often think of the moon as a tranquil, unchanging presence in our night sky, a silent observer of life on Earth. But beneath this calm facade lies a force of immense power. The moon's gravitational pull is a cosmic thread that binds it to our planet, shaping our world in profound ways. From the rhythmic rise and fall of ocean tides to subtle changes in the atmosphere, the moon's influence extends far beyond what meets the eye. Today, we explore the moon's gravitational pull and how this invisible force touches every corner of life on Earth. The moon's gravitational pull is a fundamental force that has been at work since the dawn of our planet. This force is most famously associated with the tides. As the moon orbits Earth, its gravitational pull creates bulges in the oceans, leading to high and low tides. But the story doesn't end there. Tidal forces, while most visible in the oceans, also stretch Earth's crust and even its atmosphere. These distortions, though subtle, ripple through our environment, influencing ecosystems, weather patterns, and geological activity. Imagine this. The very ground beneath your feet is slightly stretched and compressed as the moon pulls on Earth's surface, a phenomenon known as Earth tides. Though imperceptible to us, these shifts are powerful reminders of the moon's enduring grip on our planet. Another critical impact of the moon's gravitational pull is its role in slowing down Earth's rotation. Over billions of years, the moon's tidal forces have acted as a brake, gradually lengthening our days. Today, Earth's rotation slows by approximately 1.4 milliseconds per century. 4 billion years ago, a day on Earth was only about 6 hours long. Without the moon's gravitational influence, our world might still be spinning at dizzying speeds. This slowing down has not only given us longer days, but has also stabilized our planet's climate and made life as we know it possible. The stabilizing effect of the moon on Earth's axial tilt is equally vital. Without the moon, Earth's tilt would wobble chaotically over time, leading to extreme and unpredictable climate shifts. Instead, the moon acts as a cosmic anchor, maintaining a steady tilt of approximately 23.5 degrees, perfect for sustaining the seasons and a relatively stable climate. Beyond the land and oceans, the moon's pull also extends into our atmosphere. Research has shown that the moon influences atmospheric pressure and even rainfall patterns. During a full moon, for example, slight increases in atmospheric pressure can lead to shifts in wind patterns. These effects might seem minor, but they can have significant implications for weather systems. Changes in wind patterns and pressure influence cloud formation, storms, and even the likelihood of droughts or rainfall in certain regions. One particularly intriguing phenomenon is the potential link between the Moon's gravitational cycles and wildfire conditions. During certain lunar phases, changes in wind strength and direction could exacerbate dry conditions, creating the perfect storm for fires to ignite and spread. This connection between the Moon and the atmosphere hints at a delicate balance, a celestial dance that shapes the environment in ways we are only beginning to understand. Throughout history, humans have recognized and relied on the Moon's gravitational influence, even without fully understanding it. Coastal communities timed their fishing and farming activities with the tides, while sailors navigated the seas guided by the Moon's phases. In ancient times, the Moon was revered not just as a symbol of mystery, but as a force of life, a celestial guide that governed the rhythms of nature and human survival. Today, modern science has allowed us to measure and model the Moon's gravitational effects with astonishing precision. Satellite data and advanced simulations have uncovered connections that our ancestors could only imagine. From how the Moon shapes ocean currents to its subtle impact on global weather patterns. The Moon's gravitational pull is a testament to the interconnectedness of our universe. It influences the ebb and flow of tides, stabilizes Earth's rotation, and even shapes the weather we experience daily. But as we'll explore further, this influence doesn't stop at the physical. It extends into the realms of ecology, mythology, and even the fires that rage across our forests. As we continue to uncover the Moon's secrets, one thing becomes clear. The invisible threads of gravity that bind Earth and the Moon are far more intricate and far-reaching than we ever imagined. The Moon's impact on weather patterns and climate. As we continue our journey through the vast and often unseen effects of the Moon, we find ourselves turning toward one of the most intricate and powerful areas of its influence: the weather. The Moon's gravitational pull doesn't just affect our oceans or the Earth's rotation. It extends deep into the atmosphere, subtly shaping weather patterns and, ultimately, the climate of our planet. For centuries, ancient civilizations believed that the Moon controlled the elements: storms, droughts, and even the cycles of rain. Today, modern science confirms that the Moon's effects on the Earth go far beyond myth. But how exactly does the Moon shape the weather? Let's explore how its cycles and gravitational forces influence the atmospheric conditions we rely on every day. One of the key ways the Moon impacts weather patterns is through its effect on atmospheric pressure. As the Moon orbits the Earth, its gravitational force causes subtle shifts in the atmosphere. These shifts are most noticeable during the full moon and new moon phases, when the Moon's alignment with the Sun amplifies its gravitational effect. During these phases, the atmospheric pressure can increase or decrease slightly, depending on the position of the Moon relative to the Earth and the Sun. The force exerted by the Moon on Earth's atmosphere causes air masses to move, leading to fluctuations in wind speeds and cloud formation. These changes can influence weather conditions, bringing with them either periods of stability or heightened volatility in weather patterns. In certain regions of the world, these changes can be felt more acutely. For example, in coastal areas where the interplay between atmospheric pressure and oceanic conditions is especially sensitive, the Moon's pull can enhance or diminish the strength of storms, from gentle rain showers to intense hurricanes. The Moon's influence can be the difference between a mild weather pattern and a rapidly developing storm system. Another fascinating aspect of the Moon's influence is its effect on wind patterns. Wind is, in essence, air in motion, driven by differences in air pressure and the rotation of the Earth. When the moon's gravitational force alters atmospheric pressure, it can accelerate wind speeds or shift their direction, influencing weather systems worldwide. At the full moon, for instance, the moon's gravitational pull can cause winds to become more intense, which in turn may stir up large weather systems such as cyclones and monsoons. Conversely, the new moon phase can bring calmer air and steadier winds, stabilizing the weather. This shift in wind patterns might not always be immediately noticeable to the naked eye, but over time, it can have a profound impact on the weather. Areas that experience regular winds, like the trade winds in the tropics or the westerlies in the temperate zones, can experience stronger gusts or even alterations in their seasonal shifts, depending on the lunar cycle. For regions susceptible to wildfires, such as the western United States, the moon's effect on wind strength and direction can influence how fires spread. Increased wind speeds, especially during certain lunar phases, can fan the flames and carry them across vast landscapes, making it more difficult to control wildfires. Perhaps one of the most intriguing ways the moon affects the Earth is through its influence on rainfall. The relationship between the moon and rainfall is not as immediately obvious as tides or wind patterns, but the effects are just as profound. Just as the moon influences the Earth's oceans, it can also influence the water cycle. In certain parts of the world, rainfall is found to follow a distinct lunar cycle. As the moon pulls on the atmosphere and ocean, it creates shifts in humidity and cloud cover, leading to increased or decreased precipitation. Research has shown that during the full moon, there is often a greater chance of rainfall as the atmosphere becomes more saturated with moisture. Conversely, during the new moon phase, some regions may experience drier conditions due to a decrease in moisture levels in the atmosphere. It's not just the amount of rainfall that is influenced by the moon, but also the timing. In areas where farming relies on seasonal rains, understanding the lunar impact on precipitation can help predict the best times for planting and harvesting. While this effect may seem subtle, it plays a key role in agricultural practices, particularly in regions that experience monsoon seasons. But the moon's influence doesn't stop at the gentle fluctuations in rain or wind. It also has the potential to amplify extreme weather events. One of the most significant ways the moon's gravitational pull affects Earth's weather is by enhancing the intensity of storms, including hurricanes and cyclones. Hurricanes, for example, are influenced by both the temperature of the ocean and the atmospheric conditions. However, when the moon is in certain phases, its gravitational pull can increase the tidal forces on the ocean, leading to stronger storm surges. These surges, in combination with other atmospheric factors, can cause hurricanes to grow larger and more destructive. In areas where these extreme weather events are common, such as the Caribbean or the Southeast United States, the moon's role in these catastrophic storms is an essential factor in predicting their potential impact. The phases of the moon are studied alongside other meteorological data to determine when storms are likely to intensify. As we move forward in our understanding of the moon's influence on Earth, it's important to consider its role in the broader context of climate change. While the moon's gravitational effects are subtle, they have been at play for billions of years. As climate change accelerates, these forces may play a larger role in shaping the long-term patterns of our planet's weather and environment. The moon's gravitational pull affects the Earth's axial tilt, which in turn impacts long-term climate cycles, such as ice ages. But more immediately, the moon's effect on weather, specifically the cycles of storms, precipitation, and temperature fluctuations, could be an overlooked contributor to the changing weather patterns we are witnessing today. The moon's effect on weather is a testament to the interconnectedness of Earth's systems. From the ebb and flow of the tides to the patterns of wind, rain, and storms, the moon's gravitational forces shape the very fabric of our atmosphere. While its influence may be subtle and imperceptible to the naked eye, its impact is undeniable. As we continue to uncover the mysteries of our universe, one thing becomes clear. The moon, in all its quiet majesty, is far more than a celestial ornament. It is a driving force in the ongoing dance of Earth's weather systems, with profound implications for our planet's climate and environment. Moon's role in ecosystems and fire dynamics. The moon's influence on Earth extends far beyond tides and weather. It touches the very ecosystems that sustain life. Its cycles guide the behaviors of countless species, from nocturnal predators to plants that respond to its faint light. But what happens when these natural rhythms intersect with one of the planet's most destructive forces? Fire? In this final part of our exploration into the moon's impact, we'll uncover how its presence shapes ecosystems and plays a surprising role in the dynamics of wildfires. For millennia, life on Earth has adapted to the rhythms of the moon. Many species rely on its light and gravitational cycles to time their movements, behaviors, and even reproductive patterns. Take, for example, nocturnal predators like owls and wolves. During a full moon, the increased light gives them an advantage, allowing them to hunt more efficiently. Prey species, on the other hand, often retreat into the shadows, seeking safety from these heightened risks. Plants, too, are not immune to the moon's influence. Some species exhibit changes in growth patterns depending on moonlight intensity. The moon's cycles also affect pollination, as insects like moths are more active during specific lunar phases, helping plants reproduce. This delicate balance between light and life illustrates how deeply interconnected Earth's ecosystems are with the moon. But when these ecosystems are disrupted by drought, heat, or human activity, the consequences can be devastating. Dry ecosystems, such as forests prone to wildfires, are particularly sensitive to the moon's subtle effects. One of the key factors influencing fire dynamics is the level of moisture in vegetation and the surrounding environment. The moon's gravitational pull, by impacting atmospheric pressure and humidity, can indirectly contribute to creating the conditions for fires. During certain lunar phases, changes in wind strength and direction, coupled with lower humidity levels, can accelerate the drying of vegetation. This creates what fire scientists call fuel, the dry leaves, branches, and undergrowth that act as kindling for wildfires. The full moon's bright light can also alter the activity of animals that help manage these ecosystems. Grazing animals like deer and elk may avoid open areas during full moons, allowing vegetation to grow unchecked. Over time, this accumulation of plant matter can increase the risk of severe fires. Once a fire ignites, the moon's influence doesn't stop. Wind patterns altered by the moon's gravitational pull can determine how quickly and in which direction a fire spreads. For instance, during certain lunar phases, the combination of increased wind speeds and dry conditions can fan the flames of a wildfire, transforming a small, contained burn into a raging inferno. Conversely, calmer winds during a new moon phase may help slow the spread of fires, giving firefighters a crucial window to bring them under control. These interactions highlight the moon's indirect but undeniable role in the dynamics of wildfires. Understanding these patterns could provide valuable insights for managing and mitigating fire risks in vulnerable regions. While wildfires can be devastating, they also play a critical role in rejuvenating ecosystems. After a fire, the land undergoes a natural process of recovery. And here, too, the moon has a part to play. Plants that regenerate after a fire often rely on light and moisture to sprout and grow. During the waxing moon, increased nighttime light can accelerate germination in certain species, helping to kickstart the recovery process. Animals also play a role in this recovery. Species like rodents and birds help disperse seeds across burned landscapes, contributing to reforestation. The moon's light guides their movements, ensuring that these critical ecological processes continue even after a fire. In this way, the moon serves not only as a silent witness to destruction, but also as a catalyst for renewal, guiding the rhythms of life that allow ecosystems to heal and thrive once more. Today, scientists are working to uncover the full extent of the moon's influence on ecosystems and fire dynamics. By studying the interactions between lunar cycles, weather, and vegetation, researchers hope to develop new tools for predicting and managing wildfires. For example, satellite data combined with lunar phase modeling could help identify periods of heightened fire risk, allowing authorities to take preventative measures. Firefighters might one day use these insights to determine the best times to combat active fires or conduct controlled burns. As we deepen our understanding of the moon's role in fire dynamics, we open the door to innovative solutions for protecting both nature and communities from the devastating impacts of wildfires. The moon's role in ecosystems and fire dynamics is a reminder of the interconnectedness of all things. From guiding the behaviors of animals to influencing the spread of flames, its presence is felt in even the most unexpected ways. As we continue to explore these connections, we gain not only a deeper appreciation for the moon, but also a renewed sense of responsibility for our planet. The same celestial force that has inspired awe for millennia also holds the keys to understanding and perhaps mitigating some of Earth's most pressing challenges. Wildfires in the United States and contributing factors. The anatomy of a wildfire. Understanding its causes. Wildfires, one of nature's most destructive forces. They burn through millions of acres each year, devastating landscapes, communities, and lives. But behind every wildfire lies a complex web of causes. Understanding these causes is not just a scientific endeavor. It's a critical step toward prevention and resilience. In this section, we'll dissect the anatomy of a wildfire. What starts them, what fuels them, and why they've become so frequent and intense in recent years. Wildfires begin with a spark, sometimes literal, sometimes metaphorical. But what ignites that spark? Nature has its own way of starting fires. Lightning is one of the most common natural causes. A single lightning strike, especially during dry conditions, can ignite a blaze that spreads for miles. Volcanic eruptions, though rare, can also trigger wildfires when lava or hot ash meets combustible vegetation. These natural ignition sources are as old as the Earth itself, part of a cycle that has shaped ecosystems for millennia. But today, human activity is responsible for the majority of wildfires in the United States. Campfires left unattended, discarded cigarettes, and even sparks from equipment can start devastating fires. In some cases, arson, deliberate acts of setting fires, has been a contributing factor. These human causes whether accidental or intentional, highlight the delicate balance between our actions and the environment. While the causes of wildfires may seem straightforward, their frequency and intensity have been exacerbated by a powerful underlying force: climate change. Rising global temperatures have created conditions that are ripe for wildfires. Heat waves are becoming more frequent and prolonged, drying out vegetation and turning it into fuel. In the western United States, where wildfires are most prevalent, average temperatures have risen by nearly 2 degrees Fahrenheit in the last century. These hotter, drier conditions are a direct consequence of a warming planet, making wildfires not just more likely, but almost inevitable. Climate change also influences the timing of natural ignition events. Lightning, for example, is expected to increase as global temperatures rise, further adding to the risk of wildfires. Once a spark ignites, it needs fuel to grow. And in a wildfire, that fuel is all around us. In forests, dry leaves, dead branches, and undergrowth provide ample material for fires to consume. In grasslands, tall, dry grasses act as kindling, spreading flames rapidly across open landscapes. The availability of fuel is what determines the size and intensity of a wildfire. And today, there's more fuel than ever before. Decades of fire suppression policies have led to the accumulation of combustible material in many forests. While these policies were intended to protect landscapes and communities, they've inadvertently created conditions for larger, more destructive fires. By suppressing smaller, natural fires, we've allowed fuel to build up to dangerous levels, turning forests into tinderboxes waiting for a spark. Fuel is just one part of the equation. Weather and topography play a critical role in how wildfires spread. Wind is perhaps the most significant weather factor. Strong winds can fan flames, pushing them across landscapes at incredible speeds. They can also carry embers, tiny burning fragments of vegetation, miles ahead of the main fire, starting new blazes in a phenomenon known as spotting. During extreme wildfire events, wind speeds can make the difference between a manageable fire and an uncontrollable inferno. The shape of the land also influences fire behavior. Fires tend to move uphill faster than downhill, as heat rises and preheats the vegetation ahead. Canyons and valleys can act as funnels, directing wind and intensifying fire spread. These natural accelerators make certain areas particularly vulnerable to wildfires, turning what might have been a small, contained burn into a devastating disaster. Finally, the way we use and develop land has added another layer of complexity to the wildfire equation. Urban expansion into fire-prone areas, known as the wildland-urban interface, has placed more communities in the path of wildfires. Homes built near forests or grasslands are at greater risk, and firefighting efforts are often complicated by the need to protect both people and property. As we build closer to nature, we increase our exposure to wildfires, making it essential to rethink how and where we develop our communities. The anatomy of a wildfire is a story of sparks and fuel, weather and terrain, and the choices we make as humans. Each element plays a part, and together, they create the perfect storm for destruction. Understanding these factors is not just about prevention. It's about preparing for a future where wildfires are an ever-present reality. The escalation of wildfires, climate change, and human activity. Wildfires are not a new phenomenon. For millennia, they've been part of Earth's natural cycle, shaping ecosystems and renewing landscapes. But in recent decades, wildfires have escalated in both frequency and intensity. Why? The answer lies in a combination of two powerful forces: climate change and human activity. In this section, we'll explore how these forces are driving the wildfire crisis to unprecedented levels, turning what were once manageable fires into catastrophic events. Climate change is reshaping the world as we know it. Rising global temperatures are making hot, dry conditions more common, perfect for igniting and spreading wildfires. Droughts are becoming longer and more severe, especially in the western United States. These dry spells reduce soil moisture and kill vegetation, leaving behind vast stretches of brittle, flammable material. Without adequate rainfall to replenish the land, forests become tinderboxes, ready to ignite at the smallest spark. Warmer air holds less moisture, creating conditions that dry out forests even faster. Over the past century, the average temperature in fire-prone regions of the U.S. has risen by nearly 2 degrees Fahrenheit. These seemingly small changes have significant consequences, accelerating the drying process and extending the wildfire season. The wildfire season, which once lasted a few months, now stretches nearly year-round in some regions. As global temperatures rise, so does the frequency of lightning, a natural wildfire ignition source. Hotter air leads to more intense storms, which produce more lightning strikes. Studies suggest that lightning activity could increase by up to 12% per degree of warming, adding another layer of risk to already vulnerable landscapes. With more lightning strikes comes more opportunities for fires to ignite, creating a dangerous feedback loop of heat, drought, and fire. While climate change sets the stage for wildfires, human activity often provides the spark. Over 80% of wildfires in the United States are caused by people. The wildland-urban interface, areas where human development meets forests or grasslands, has grown significantly over the past few decades. As more people move into these areas, the risk of wildfires increases. Homes, roads, and infrastructure not only create ignition points, but also complicate firefighting efforts. The closer we build to nature, the greater the risk of fire, and the harder it becomes to protect both lives and property. Human negligence is another major factor. Activities like campfires, fireworks, and machinery use can easily ignite dry vegetation. Even something as small as a discarded cigarette butt can start a fire that spreads for miles. These accidents are often preventable, yet they account for the majority of wildfire ignitions, highlighting the need for greater awareness and responsibility. In rare cases, wildfires are intentionally set. Arson, whether driven by malice, mental illness, or other motives, can cause devastating damage. While these incidents represent a small percentage of ignitions, their impacts are often disproportionately large. Every deliberately set fire represents not just a loss of land and wildlife, but a betrayal of the communities that rely on these landscapes. The relationship between wildfires and climate change is not one-sided. While climate change fuels wildfires, the fires themselves contribute to climate change, creating a dangerous feedback loop. When forests burn, they release massive amounts of carbon dioxide into the atmosphere. In 2020 alone, wildfires in the United States emitted over 200 million metric tons of CO2, equivalent to the annual emissions of 44 million cars. These emissions exacerbate global warming, which in turn creates conditions for more intense and frequent fires. Forests act as carbon sinks, absorbing CO2 from the atmosphere. When they burn, not only is stored carbon released, but the forest's ability to absorb future emissions is also diminished. This loss further accelerates climate change. Every acre of forest lost to fire represents not just an environmental tragedy, but a setback in the fight against climate change. The escalation of wildfires doesn't just affect the environment. It impacts people and economies on a massive scale. Every year, tens of thousands of people are forced to flee their homes due to wildfires. The emotional toll of losing homes, communities, and even loved ones is immeasurable. For those caught in the path of a wildfire, the experience is nothing short of life-changing. Wildfires cost billions of dollars annually in damages, firefighting efforts, and lost economic activity. In 2020, the United States spent over $16 billion fighting wildfires, a figure that doesn't account for indirect costs like lost tourism and healthcare expenses from smoke inhalation. As wildfires grow more frequent and intense, the financial burden on communities, states, and nations becomes increasingly unsustainable. The smoke from wildfires poses a significant health risk, especially to vulnerable populations. Fine particulate matter in wildfire smoke can cause respiratory issues, heart problems, and even premature death. The effects of wildfire smoke are not confined to the fire zone. They can extend hundreds of miles, impacting millions of people. The escalation of wildfires is a story of interconnected forces: a warming planet, human activity, and the natural cycles of fire. Together, they create a crisis that touches every aspect of life: environmental, economic, and personal. Understanding these forces is essential, not just for responding to the fires of today, but for preventing the infernos of tomorrow. The role of weather patterns and topography in fire behavior. As we've seen, climate change and human activity set the stage for wildfires, creating the conditions for ignition and growth. But once a fire begins, its behavior is shaped by two critical factors: weather patterns and topography. Together, these elements determine how fast a fire spreads, how intense it becomes, and which areas are most vulnerable. In this section, we'll explore how these forces interact with wildfires, turning small sparks into raging infernos. Weather is one of the most dynamic forces affecting wildfires. It can either accelerate their spread or provide a temporary reprieve for those fighting them. Wind is often the most decisive factor in how a wildfire behaves. Strong winds fan flames, driving them across landscapes at incredible speeds. Winds can also carry embers, small, burning fragments of vegetation miles away from the main fire, starting new blazes in a phenomenon known as spotting. During extreme wildfire events, wind speeds can transform a manageable blaze into an uncontrollable disaster. Gusts of just 30 miles per hour can double the size of a fire in minutes. Certain wind patterns, such as the Santa Ana winds in California or the Chinook winds in the Rockies, are notorious for their role in intensifying wildfires. These hot, dry winds blow across already parched landscapes, further drying out vegetation and creating the perfect conditions for rapid fire spread. Humidity, or the amount of moisture in the air, plays an opposing role to wind. High humidity levels can slow a fire's growth by keeping vegetation damp, making it harder to ignite. However, in many wildfire-prone areas, humidity levels often plummet during the fire season. This is particularly true during hot, dry afternoons, when relative humidity can drop to critical levels. Fires that ignite under these conditions spread rapidly and burn intensely, consuming everything in their path. Understanding the interplay between wind and humidity is crucial for predicting how a wildfire will behave and for protecting communities in its path. While weather shapes the external conditions of a fire, topography, Earth's natural contours, determines how fires move across the landscape. Fires spread more rapidly uphill than downhill. This is because heat rises, preheating the vegetation above the fire and making it more flammable. For every 10-degree increase in slope, the speed of a fire's spread can double. In mountainous regions, this effect can turn small fires into devastating blazes, particularly in areas where canyons and valleys act as funnels for wind and flames. On the other hand, certain topographical features can slow or stop a fire. Rivers, rocky outcrops, and barren landscapes often act as natural fire breaks, preventing flames from spreading further. These natural barriers are critical in firefighting efforts, providing safe zones and strategic points for controlling the spread of flames. While weather and topography each play a role in fire behavior, their combined effects can be even more powerful. Canyons and valleys often channel wind, amplifying its speed and intensity. Fires in these areas can spread unpredictably, making them especially dangerous for firefighters and nearby community. These wind funnels are one of the reasons why fires in certain areas, like California's Sierra Nevada foothills, are so notoriously difficult to control. In extreme cases, wildfires can create their own weather systems known as firestorms. These intense blazes generate massive amounts of heat, causing air to rise rapidly and creating powerful updrafts. Firestorms are a terrifying reminder of the raw power of nature, where the fire itself becomes a weather event, feeding its own destruction. In November 2018, the Camp Fire became the deadliest wildfire in California history, claiming 85 lives and destroying nearly 19,000 structures. Strong winds drove the fire through the town of Paradise at an unprecedented speed. Coupled with steep terrain and critically low humidity levels, the fire overwhelmed efforts to contain it, spreading across 153,000 acres in just a few days. The Camp Fire was a tragic example of how weather and topography can combine to create the perfect storm for destruction. In October 2020, the East Troublesome Fire in Colorado grew by an astonishing 100,000 acres in a single day. Fueled by strong winds, dry conditions, and the region's rugged terrain, the fire became one of the largest in Colorado's history. This rapid expansion highlights the dangers of unpredictable weather and challenging topography, which can turn even a small fire into a massive disaster overnight. Understanding the role of weather and topography in wildfire behavior is essential for improving prediction models and firefighting strategies. Advanced technologies, such as satellite imagery and computer simulations, now allow us to predict how fires will spread under specific conditions. These tools help firefighters allocate resources more effectively and issue timely evacuation orders, saving lives and proper. While we can't control the weather or reshape the land, understanding these forces gives us a critical advantage in the fight against wildfires. Weather and topography are the silent architects of wildfire behavior, shaping how fires move, grow, and ultimately impact the land and communities in their path. By studying these forces and learning to predict their effects, we can better prepare for the challenges ahead, turning knowledge into resilience in the face of an escalating wildfire crisis. Science is the bridge between understanding the problem and finding sustainable solutions. The fight against wildfires is a story of challenges and triumphs. It's a battle fought on many fronts, by firefighters and scientists, by communities and individuals. While the wildfire crisis is daunting, it's also a call to action. By embracing innovation, working together, and learning from the past, we can build a future where fire is not just a threat, but a force of renewal and resilience. Thank you for watching. Don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep exploring.